contrast of three technologies: RPA, or Robotic Process Automation; SOA, or Service-Oriented Architecture; and my Service-Oriented Dynamic Orchestration service. Robotic Process Automation is a new term for a long-standing technique of taking screens and extracting information from those screens and reusing that information in a following screen or another screen entirely. This started way back in the mainframe days with 3270 green screen terminals, and was a way of extracting information from an existing system without having to go in and reprogram that existing system. That's the same thing they're doing now. The difference is, with RPA tools in 2018, they allow a lot more flexibility. They allow a lot more options on the kinds of screens they can interact with, on the APIs they can interact with, and even interact directly with the database and back-end APIs. The result isn't a bunch of physical robots sitting in front of terminals. It's really software that runs after you program it, either by example, by having it monitor you while you're acting as a user, or in some level of programming. So it's a software tool. It is not a physical robot. RPA is best for automating repetitive user operations. So if you've got a user that is sitting there and loading a bunch of documents and then scanning through those documents and extracting information and re-entering information and applying business rules to the data so that the process can continue, then RPA might be an excellent choice for that. A service-oriented architecture, as in this diagram, a service-oriented architecture on an enterprise service bus, allows you to create services that standardize the service contracts and allow for easy connection between multiple services and the underlying systems, APIs, databases, and the consumers of that data, whether it be a browser or an app or an application or a solution or big data or whatever it might be. So a service-oriented architecture is a means of connecting various consumers and producers in a standardized way. SOA, and especially SOA on an ESB, is best for shared resources in processes. So the process may go from application A's API to application B's API to a database to application F and their API, and then back to B and then back to A. That's the kind of process you can build on a SOA ESB. The enemy is point-to-point communications. If you have point-to-point communications like you see here, each one of those black arrows is a communications connection from one application to another. It usually requires at least one, and sometimes both ends of that arrow, to be custom code that adapts the API. The APIs can be REST or SOAP or a Java API or a .NET API or whatever it might be. Whenever you have all of those applications talking to each other and point to point, you have a lot of code, a lot of complexity, and a lot of cost. This is the current suite of technologies that are being employed across enterprises today. We have the robotic process automation that allows you to then automate the repetitive user tasks. You have artificial intelligence, which allows you to extract information, have a learning system that watches and learns and can produce an output that is a sequence of steps or a set of rules, and that works with the RPA. And then ETL, extract, transform, and load, that is used for getting data from one source, transforming it, and putting it into another source and that can work with the processes of AI and the RPA. ETL also works very well in an enterprise service bus environment, as do APIs. The APIs in a service-oriented architecture can be standardized. They can have a standard protocol with a standard canonical schema, and they can then share data and be routed through a process and reuse the underlying components. And then most of the RPA tools now have a bunch of ready bots. They're robots that are already there. They're designed to be tailored to individual systems, but they already accomplish various IT tasks, HR tasks, business tasks like invoicing and reporting, and these all can work together if you have a system that is architected for that. RPA does nothing to reduce point-to-point integration. There is absolutely nothing in the RPA suite that allows you to then reduce the number of point-to-point integrations. So RPA is not the sole solution. You need something underneath it, like a service-oriented architecture with its standardization, to accomplish the task of reducing point-to-point integration. A service-oriented dynamic orchestration service, such as the one that I've produced, is based on one of my patents, and it allows a database to control the orchestration of a series of steps in a process. It works with RPA, SOA, and an ESB. A database controls the process steps. Each process step will have one row in a table, and that row contains instructions. To change a process, you update the table, and there's no code necessary. At each step, the database table provides instructions to do the following. It can route the data transport object from one service to the next. It can actually provide a route of the entire process from A to Z and back. It can execute at a particular step a rule script. So the rule can then look at the data in the data transport object and make a decision. And that decision can affect the next step or modify the data in some way. It can also execute an ECMA script, such as JavaScript, where you can do if-then-else statements, you can manipulate the data in some way, you can interoperate with external systems. There's a lot of things you can do in a JavaScript. You can execute a Java class. The instruction will tell you what Java class to instantiate. It instantiates an instance of that class and executes it. And that Java class then has the full power of Java available to it to do anything that you might need. So there's virtually no limit to the instructions that can be executed by the service-oriented dynamic orchestration service at any given step. It can initiate parallel processes. It can say, okay, send the DTO to service C and service F to be joined later. After A and C, or A and G, or whichever, have been executed, they can then be aggregated by the service-oriented dynamic orchestration service into one ongoing data transport object. It can even modify the Sodos database itself. So it can change instructions, it can add steps, it can remove steps, it can be very useful in doing things like detecting an error, logging it, and then maybe finding out that there's some piece of data that needs to be looked at, and adding another step to the process that does a detailed log between step C and D. So what are the benefits of this system, where you have RPA managing the front end, you have a SOA ESB in the middle, and then you have a service-oriented dynamic orchestration suite that is executing the processes. The first and probably the biggest benefit is agility. Your agility is improved because you can make changes on the fly. You don't have to shut the system down to make an adjustment. You don't have to do reprogramming to change the flow. You don't have to do anything code-wise to be able to debug it, because you can add a logging step before and after, and detailed information is extracted to give you the information you might need to fix it. Improved reuse. If you think about it, with a service-oriented architecture and a standardized service contract, all of the services then would have the same the same endpoint interface, the same canonical schema, the same protocol. That means that the services can then be called in any sequence that you like, provided the data that the service needs is available in the data transfer object. So improved reuse is a sideline benefit. It isn't the goal, but it's what happens when you standardize everything. Reduced coding, the same thing. If you have standardized service contracts, standardized protocols, standardized canonical schema, then what happens is that your code becomes simpler, because all you have to do is the business logic or the mapping of the API that you're calling inside that one service. Increased standardization. By having one level of standardization, it makes all of the others easier to standardize. So your RPA now has standard interfaces to interact with. You don't have to then figure out how to interact with this service and that service and provide different adaptation to each one. They're all standardized. And with the increased standardization, you get reduced maintenance, because all of the code is now standardized, all of the interfaces are now standardized. You have less code, which means easier to maintain and easier to improve on down the road. You have improved integration. The standardized service contracts and the enterprise service bus and all of the services that are provided by that improve the integration opportunities. It allows you to do throttling, it allows you to do error handling, and all of that improves your integration. The biggest benefit, though, is probably reducing the point-to-point integrations. Each service, each API that you want to integrate with will have one, not one times the many of connections, but one interface that you publish on the ESB. Then anyone that wants to use it will just call that endpoint, pass it the canonical schema with the data it needs, and get a result. So you reduce point-to-point integrations by a factor of 5, 6, or 7, or maybe even more, depending on how many systems you have are integrated today. So to sum it up, RPA, SOA, especially SOA on an ESB, and my service-oriented dynamic orchestration service all combine to give you the best of all of the technologies that we mentioned. Thank you very much.